Hi, good morning. I'm Spencer Erling. I'm one of the independent judges on the panel.
Great. Franco?
Franco Mordini, look at the tubes side of things, but also participate obviously in the other entries as well.
Great. Emmanuel?
Hi, Emmanuel here with the Steel Institute, and I'm here to look at the engineering side of the project.
Okay, Tulani.
Hi everyone, Tulani Sivande, Director Paragon Architects, representing architecture in this jury platform.
John Duncan?
Greetings, I'm a second independent judge. Like Spencer, we've been involved in steelwork for our whole lives.
Great. So I think this is about us. I think if anyone else joins in, we can just greet them as they come in. Kevin, I believe that you've prepared a PowerPoint presentation in line with our brief that we've sent through. So if you want to share, I just want to double check that the sharing is sorted. All participants can share, so you should be able to share now.
Okay.
And then also from a architectural perspective, Michael, if you want to just jump in at any stage, that's fine. You can just jump in as well if there's something that you'd like to highlight as we go along. And I'm going to put myself on mute. And Kevin, the floor is yours if you want to go for it.
All right. Good morning, everyone. My name's Kevin. I'm from KANTEY and Template Consulting Engineers. We did the civil and structural engineering on this project, so I was heavily involved in the structural engineering on the steel structure, and the rest of the team members, I suppose we can introduce them as we get to their respective points in the presentation. So what we've done is we've just prepared a basic PowerPoint presentation just to help guide the process in the discussion, and then I suppose if anyone would like to stop and ask questions, then those questions will be most welcome, and we'll help answer them as best we can. So
just one little note from my side. We are on a 40-minute time limit, so when we do get a little closer to the end, Kevin, I'll just notify you by private message, and then we'll need to start wrapping up on the judges' questions. So
yeah, we'll try and keep it brief and concise, and we'll just answer the questions that come up. Okay, so the first slide is just the project description and title, as well as the relevant team members and role players. And these are the company logos just for the companies that were involved. Starting off with from a structural perspective, this is a conventional, very typical warehouse with a combination of structural steel trusses and lattice girders, and in this case we've got a column grid of 24 by 24. However, what is unique to this particular warehouse is that in order to work well with the tilt-up panels and with the floor slabs, we went for an 8-meter base spacing. Now, obviously, when you're doing your purlins, you want to try and make them continuous over at least 2 spans to help manage the deflections. So that was an interesting challenge, because the transportation of 16-meter long purlins can be an issue. But we put that in our tender data that we wanted 16-meter long purlins, and the contractor PARAGON was able to get them fabricated to that length and able to deliver them to site and erect them. So in the end, we ended up with an efficient solution there, which was good. Another interesting aspect on the warehouse is we've got these large cantilever gable wing walls, which you'll see shortly. We also had an interesting apex, sort of angled step on the apex that needed some careful consideration. And then on the predominant wind-facing side, we also got a number of doors, large sectional doors. So we just needed to manage wind risk carefully. And we also, over the loading docks, we had some very large spans that we needed to manage in an aesthetically pleasing way. And then finally, there were some construction challenges, which I'll get to, and I'll address each of those points just using slides, just to help provide visual aid and information, because it just makes it a little bit more interesting. So this is the particular model of the building. With regards to the wing walls, what we did was we made use of hot rolled steel on the girts that extended into those wings, so that we could get the strength that we needed, so that those cantilevers could work, because they're obviously highly exposed, and we needed to manage that very carefully. And what we did was we were able to use hot rolled sections that were very similar in size to the cold rolled sections, and internally we painted them silver, so you almost couldn't distinguish between the two. And obviously they worked well and gave us the strength that we needed to cantilever out on those wings. And we also had to be careful with those connections back to the columns as well, just to make sure. So you can see the connections to the concrete columns there. We ended up adopting double cleats with additional anchors. This is the shop detailing of the 45-degree apex step, and as you can see, there's a lot of careful considerations that we had to make there to get the benefit of the structural continuity, but also to manage bracing without ending up with clashes all over the place. So that was quite interesting, but we managed to resolve that, and we ended up with an efficient design there. And then another thing which is possibly unique, I don't know if you guys have come across this before, but what we were able to do is we were able to work with the mechanical engineers, and we were able to integrate the mechanical ventilation system into a wind risk management process, where we interlocked the weather station into the louvers and the fans, the ventilation fans in the building, as well as the sectional doors. So that weather station measures wind speed, but it also measures, determines the wind direction. And obviously with such a large loading canopy, there's going to be some confinement of wind under that canopy. And what we were really after was we wanted to try and manage the development of high internal wind pressures within the building. So that weather station is interlocked with the sectional doors, which are motorized, as well as the ventilation fans. So when you have a high wind, for example, from the loading canopy side, the sectional doors are closed and they cannot be opened. The fans and the louvers on the wind-facing side, the louvers are closed and the fans are turned off, and then the fans and the louvers on the leeward side are turned on, and that just helps to eliminate any pressures that do develop from around the perimeter of the building. So that was quite innovative and something unique that adopted. We haven't relied on it from a design point of view, but we felt that it was important to manage it, especially with climate change and high wind scenarios are happening more frequently. So that was something that we were able to do there. And then on the loading canopies, there we had large spans to manage, and we needed to try and make it architecturally pleasing and tied in with the rest of the structure. And there we were able to get a triangular tubular truss to work, and those trusses are spanning 32 meters. We integrated the foundation into the loading dock, so we didn't need to have separate foundations for those. And we were also able to conceal the downpipe from the box gutter within the columns. So it's given a very nice, neat solution, and those columns are galvanized. So just in case there is any leakage at some point in the future, at least they won't be compromised from a structural perspective. And these are just some different perspectives of that. And then the final other challenging aspect, and I think it arises quite often with assembling or erecting these large slender trusses, is just to erect them safely without them buckling. What we did in this project is we assembled the trusses as pairs on the ground, and then did tandem lifts to lift them up. And the benefit of that obviously is that the large majority of the work which is done on the ground, which is obviously a lot safer. And then and then obviously the structural integrity of the trusses is maintained, and you don't run the risk of damaging them during the erection process. So it also obviously speeds up the process significantly, because obviously work in the air is slower, whereas work in the ground is faster. And this way teams on the ground could progress ahead of the teams that were actually rigging the trusses into place. So yeah, it worked extremely well in the end. And yeah, so in terms of why steel, I think obviously for a large warehouse, it's an obvious choice, but there are significant benefits in terms of time, because a large portion of the structure is fabricated off-site, which obviously means that the on-site installation is a lot quicker, and with the structural steel, and particularly the trusses, you're able to end up with a very efficient, lightweight construction. And then finally, just what we would consider to be the most impressive achievement from a structural point of view would be that this building has such pleasing aesthetics and such interesting aesthetics, and sort of striking angular features, yet we were able to design it structurally in a very, very efficient way. So this, although it's very aesthetically pleasing, the client hasn't had to pay for that in terms of a premium to the tonnage of the steel. This box still weighs much the same as a conventional rectangular box, yet it looks significantly more impressive than that, especially considering its proximity to the main N3 between Durban and Pietermaritzburg. So there you can see just how close the N3 is, and because this building is up on a platform, it really has prominence when you drive past, and I think the client really benefits from that. And that's basically what that elevation looks like. So it's really, really, really looks good. And next, we're moving on to the architectural aspects, and I'm going to hand over to Mark for that side of it.
I was just about to suggest that. You beat me to it.
Sorry, let me just, 1 second, Mark. Sorry, there.
That's perfect. Thanks. Yeah, guys. Thanks, Jan. Most importantly at this point, it's thanks to our team for pulling this job together. We're extremely proud of it, and everybody pulled together and got a project together that we're happy to put forward. I think obviously, for fear of repeating what Kev's already said, it's important to note that the building is in quite a unique position in terms of logistics to get to it, and obviously with any warehouse type building, I think it's clear that the two most critical parts of a functional warehouse space is to make sure you have as uninterrupted internal spaces as possible, and your yard works. And in terms of the steel aspect, I mean, steel makes that uninterrupted space possible where most other materials won't. So we've certainly benefited from the use of steel and very clever design from our engineers, and the building serves to show that. The brief task very quickly was a distribution center, which we did through our client being GROWTHPOINT Properties for a client of theirs, which is Baker's Transport. And they have a relationship where they wanted to create a warehouse facility to serve that relationship. They also elected to put their main head office on this site, which we've incorporated closer towards the freeway to give them as much exposure from an advertising perspective as possible. The site itself, being between Maritzburg and Durban, as Kev mentioned, is on a bit of an Acropolis type position, and that gives us obviously very much big opportunities, if you like, from a visibility perspective. You can see the site and particularly where we positioned the warehouse and office from kilometers away. So we really needed to make sure that that we positioned the buildings to engage with the freeway to a certain degree and to create some form of interest. How we did that with the steel was by stepping the roof planes and modulating the facades, which we were able to achieve considering the wind things, the wind pressures, etc., that we had to take into account. And in those articulations, we were able to introduce translucent sheetings, etc., to allow natural light in, which obviously would benefit us from a green rating. In terms of the daytime usage of this building, they sometimes don't have the lights on, or on alternate occasions they will only have 50% of the light banks on, which is important to us as architects in terms of trying to design efficient buildings. We've got these large wing walls and overhangs along our eaves, which not only create a very lightweight frame elevation to the building, which we further emphasized with the sheeting color. It also, what it did was it created shading elements, etc., for our translucent sheeting, so that we're getting the benefit of the light, but not direct light, so that the product inside, etc., doesn't get damaged. And this is important aspects that we have to consider. This stepping gable facades of the warehouse are interrupted by the office elements that work hand in hand with the warehouse. And the way we've tried to handle that is by, in a sense, slicing pieces of the lower warehouse out and inserting these offices with a white frame, which contrasts very well between the office space and the warehouse space. And I think aesthetically allows us to achieve the outcome we were looking for. With the office block itself, it's comprised of various departments being its head office. And with the freeway architecture aspect, what we've tried to do is keep a very simple linear form that engages with the road. And it's interrupted by these overscaled louver elements that are in this vertical plane. And for us as architects, it is vitally important that those things read as a more elegant element as opposed to some big chunky thing. And the only opportunity we have to achieve that is by using the framework for those louvers. Otherwise, it wouldn't be possible. So the steel aspects that we carried through from the warehouse space through into the office design to allow certain aesthetic images to work is vital to this design. Otherwise, it wouldn't be possible. Yeah, essentially, we're happy with the outcome. We believe it's working very well as it's been operational now for a couple of months. And it certainly stands out in the very remote position that it's positioned. Thanks, Kev.
We can hand over now. We can hand over to Sean from Safintra.
Good morning, team and judges. I'm Sean from Safintra Durban. I am the architectural rep that represents Safintra in the KZN region. So just moving on to the cladding. That's my video not on. Sorry about that. There we go. Moving on to the cladding specifications for this project. We were approached by professionals with regards to attending meetings and trying to figure out what colors to suggest for this project. So as you can see on the presentation, we've got here roofing specification. We use the Saflock 700 concealed fixed system, a 55 AZ200 color plus thunderstorm, which is your dark gray. Then moving on to the vertical cladding, we use the Y-Deck, which is a pierced fixed system, also a 55 thick AZ200 color plus rain cloud, which is the light gray. We had a few challenges from our side of Safintra because with the site, as you can see, we've got the picture up here. There's very minimal space for on-site rolling, which we had to do. So we had to coordinate with the team to find out where the best position would be to have the mill. And with the sheets being over 50 meters long, we needed to know where to position the mill in order to minimize movement of sheets once they have been rolled. So if I'm not mistaken, we actually rolled everything on the far right-hand side, where the building is on the right there. And then the cladding team, which was MJC and Sheldon, they then hoisted and lifted the sheets up from the side and onto the roof. So yeah, because with having such minimal spacing, it's not the easiest to be able to grant access anywhere to get these sheets on. So yeah, so specifications wise, it actually turned out very well. We're very impressed and very happy with the outcome. And I was just actually saying to the team this morning that we actually had our business head, Justin Jackson, driving down the other day, and he actually commented on the building when going past, and he said it's turned out so beautiful and stunning, and we're actually very happy with it as Safintra as a whole. So yeah, Kev, that's what I can really say.
Okay, and then we're going to hand over to Sheldon from MJC just to discuss the cladding process.
Cheers, good morning all. Sheldon from MJC. Yeah, so one thing in terms of the specification, just popping back, we also had that Opal 50 polycarbonate 1.2 millimeter sheet there. And as Mark had suggested earlier, it really did frame the building really nicely and allow a lot of natural light in. Onto the cladding process, Sean touched on the sheet length being over 50 meters. And in terms of the moving around a sheet of that length on site, firstly, it requires a lot of manpower at just over 5.8 kgs per square meter. That does start getting heavy. And then, as Sean said, we've lifted on the right-hand side of the building. If you looked at it from the previous slide, up onto the roof, and then started installing from the right, moving out towards the left-hand side of that image. That in itself, the lifting process, we had to have 2 crews on the roof lifting, as well as 2 crews on the ground, allowing straining wires or straining ropes to facilitate the lifting of a sheet of over 50 meters without it twisting or turning or buckling or anything like that. So that process was quite a coordination challenge, and we did that quite effectively and installed the roof sheets according to the 2 different slopes. Going on to some of the other items that we had there, was the vertical cladding sheets. They were all milled off-site. The vertical cladding sheets were of a length that is restricted to transport, but they fell within that restriction, which is anything over 12 meters has to be rolled on site. Anything under 12 meters can be transported to site. So a lot of the vertical cladding sheets were within that 12 meters, so we were able to transport them to site. It did start getting close to the margin when we looked at the gable end, and I think we did have a sheet that was over 12 meters that we slipped on a truck in any case. But yeah, we made it happen, and the vertical cladding sheets went on. And then there was also quite a close coordination between the vertical cladding sheets, the lighter grey, with the polycarbonates at the eaves of the building. There's a section of polycarbonate that allows a bit of light in there as well. So coordinating the merger of the cladding sheets and the polycarbonate was a little bit of a challenge, but we got it done as well. Then just to go on to the next slide, in terms that's as pretty much as it goes for the cladding process. I think in terms of steel, everyone knows and uses steel for its natural characteristics, its strength, its rigidity, and the cladding and the way in which the cladding was installed, kind of to see how a product that's got such characteristics can be manipulated into such an appealing format and used to really accentuate the building's architectural standpoints is really good to see. So the way in which the sheets are rolled on site and used to clad the building really is a testament to the architectural standpoint of that building. I often say when we're doing sheeting, it's pretty much a skirt. It's like putting a skirt on the building, and we basically just make it look pretty on that side of things. Some of the overcomings or the achievements that I'm really proud of in terms of the project itself is the actual completing the installation process. Now, a lot of the sheeting had to happen prior to any layer works or any other internal works that could happen. You know, pouring of the concrete slabs and everything like that. So all the sheeting had to be done ahead of that. So we established sites when it was very raw, in the sense that there was many excavations, piles of sand and rock and around, and we had to negotiate logistically around that, as Sean said, to mill a 50-meter sheet with a 22 on it off the back of a 22-meter long truck. You're looking at about plus over 75 meters of straight running space that you needed to mill the sheet out of, and then move that sheet into position to lift it onto the roof. That was a little bit of a challenge. So that overcoming that challenge in terms of logistics on site was quite good, and I'm quite proud of that as well. And then in terms of teamwork, I think this project was one of the smoother projects that I've definitely worked on, if not the smoothest. And I think that's just a testament to everybody's cooperation, flow of information, you know, all having a similar goal in terms of getting the building done or getting the building sheeted and looking the best possible for the client. And I think that's definitely a commendation to the team involved in the process. So yeah, hats off to the team, and thank you for working with us on such a project, and something to be very proud of. Thanks, Kev.
Right, excellent. That's it. Thanks,
Kevin.
Sheldon.
Sorry, it's Pete from Paragon here. I'd just like to add, from our side as well, it was an unbelievably seamless project. And I think a large part of that was the hands-on approach from the professionals right through to absolutely everybody involved. And when I say strict, it should be the norm, but it often falls away. Strict accordance to a QC. So we were going ahead, from the building contractors to us, we were all going ahead and saying, right, we're coming across, there's going to be an issue here because there's been a bit of a lapse on a QC, or there's a tolerance that is out. And we'd look at it as a team and push it together. And the structure went up in an unbelievably fast pace with absolutely no problems, which it all comes down to accuracy. And it actually worked very, very well. The space frames we've done a few small space frames of those 32-meter trusses, triangulated trusses. They were quite a challenge as well, getting them made and spliced and correctly and all to line up, and it's all ended up as a beautiful project. And I think it was a real hats off to the whole team involved. It was an incredible project, and really hats off to everybody. Yeah.
Can I please ask Peter a question? Peter, it's Spencer. How are you?
Very good, Spencer, and you?
Good. Peter, what about, sorry about my dogs in the background. What about the interface between the top of the concrete columns and your base plates of your columns?
So
how's that done?
The structure was quite high. The columns were, I think, in the region. Kevin, you'll know more than probably be better than me, but I'd say 15 meters.
10 meters. Yeah.
Yeah. We guessed about 12 meters.
About 15 meters high, and so in the beginning there was a bit of an issue with the boxes, the shuttering boxes that were twisting a little bit, but they sorted that out after basically day 1 or 2. But the how do you say, the
Anchors?
right from the beginning, they were going and as bolting absolutely everything. So when we came along to fit them in, we literally, the steel just fitted like a glove. It just came in and sat down. I can't, sorry, Kevin, you're going to have to come in a bit me. I'll be honest, Spencer, sorry, while I was running the project, I wasn't involved too much in the details.
So WBHO, they were doing as-built surveys, and they were feeding that information back to Paragon, and basically any adjustments that needed to be made were just being made proactively. We did also have pockets at the top of the bolts to allow for some minor movement where we needed it, but it wasn't necessary. It went really well. I think it's
the point that I'm raising is that you did cast in anchor bolts at the top of the columns.
Yes.
With pockets.
Yes, that's correct. Yeah, anchor bolts are cast. Yeah.
And it's, for those listening, it's one of those exercises where having competent surveyor on site to set that up is what enabled Peter to fly through the erection.
Yeah, that's for sure. As long as the bolts are in the right place, the steel fits like a glove, and that just makes rigging go, I would say, 3 times faster.
Yeah. It's something we should all be learning, that it's a small expense on site, but the long-term benefits are tremendous.
Yeah, correct.
Right, gents, we have about 6 minutes left for wrap-up and questions. So if there are any more questions from the judges, or if there's anything else that the project team would like to highlight, now's the time to do so.
I have a question for Kevin. Just 2 questions. One is, I didn't quite understand if your integrated wind smart system was for structural purposes or for ventilation. That was the first question. And yeah.
Yes. So the ventilation system was required from a fire perspective. So it's for smoke ventilation. Okay. And when we were discussing the doors in the project meetings, sort of right up front, I said to the guys, you know, the internal pressures on this building build up extremely quickly, especially when you have all 12 of the doors opening. And I said to the mechanical engineer, can't we interlock somehow, interlock a weather system to the doors so that those doors can't be opened? Because generally, I think it's often assumed that in extremely high winds, your roller shutter doors or your sectional doors are closed anyway. Okay, but that's a risk that you take.
Yes, it's not always true.
That's a tenant issue that's very difficult to manage. You know, whereas if it's interlocked to a weather system, then the tenant cannot they can't have doors open in high winds. And I think the issue with internal pressures is that if for some reason one sheet goes, what suddenly happens is now the wind facing side or that elevation suddenly has even the openings effectively even larger, and it can start the sort of domino effect, you know, where you start getting extremely high internal pressures. And I think the other thing is that the vast majority of these doors are confined by a very large canopy, so you're probably going to end up with some kind of funneling effect, which makes it potentially even worse. You know? So the mechanical engineer was actually able to interlock the louvers and the ventilation fans and the doors into the design of that weather station, and there's a design process there, and it's on a control system that manages it.
Okay. I've just never seen this before. That's why I was asking.
No, and I think it probably cost, you know, maybe an extra 100,000 Rand to do this. And if you consider the risk mitigation that it adds, the cost benefit of that is massive. You know, so it added extreme value to the project, and obviously I get to sleep well at night as well, which is a bonus. You know.
Only assume that all of this is supported with a massive generator in case Mr. Eskom plays games.
Yeah, so
exactly.
So there is a generator on site, which also is required for the fire pumps. So so it's all integrated, which is a good thing.
The other question, Kevin, is sorry. One more question is One more question is how light is the roof? Meaning per square meter?
20.3 kgs per square meter.
That's without purlins?
That's with the columns, but bear in mind that our concrete columns are up to 10 meters. So this is the structural steel and the girts. It was just over 20 kgs per square meter.
Includes purlins?
Includes purlins.
And those hot rolled girts.
Yes.
Yeah.
Okay, gents, we've got about 3 minutes left. Any more questions?
Just a question. Did you consider tubular trusses on the inside of the structure as well? Tubular trusses on the inside of
we didn't because of a perceived cost issue, you know, where the tonnage rate for tubular sections is obviously significantly higher. So we've always gone for angular section trusses and our sections for the trusses within the building. The reason we went for the tubular on the outside was because we needed to try and create a thin edge to that canopy. And the best way to do that was with a triangular lattice. And the best way to get the triangular lattice to look good was and connect effectively was with tubular sections. So it's sort of each decision led us in that direction.
Kevin, I think Franco will tell you that potentially tubular trusses can be substantially lighter, especially for the compression members.
Yes.
So you may have a higher rate per ton, but you've got less tons.
Yes. Look, I think it is probably something we do need to start looking at and at least investigate.
Yeah, do a rough exercise at least on the next one.
Definitely.
Sorry, just to interject there, the problem comes in with long members is just making sure that all your node points, your splice points are lining up. Which especially, well, if you're going more triangular, if you're going with a straight truss, that's okay. But if you're going with triangular trusses, it becomes quite a big problem. Yeah.
We are going to cut off shortly, so I just want to say if there are any extra questions from the judges, I will forward them through to the project team. But thank you all for your time and for your input. It's a great project, nicely done, and it was nice to see it. Great, thank you.
Thank you so much.
Thank you, everybody. Very good. Thanks.
All right.